Hi everyone! Welcome back to my channel. For today's topic, we have dividing rational algebraic expressions. We have learned from previous lesson how to multiply rational algebraic expressions. We have seen that we multiply rational expressions like we multiply fractions. And we also divide rational expressions the same way we divide numerical fractions. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. In symbols, we have A over B divided by C over D. Copy the dividend and then multiply the reciprocal of the divisor C over D is D over C. And then multiply the numerators, so we have A times D is AD, B times C is BC, where BC and D are not equal to 0. To learn how to divide rational algebraic expressions, let's start again with some simple review on how to do it in fractions. Let us have 1/2 divided by 3/4. First, copy the dividend and then multiply it to the reciprocal of the divisor. Our dividend is 1/2 times the reciprocal of our divisor is 4/3. 4 and 2 have common monomial factor and that is 2, so we divide them by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Then, multiply the remaining factors, so we have 1 times 2 is 2. Denominators, we have 1 times 3 is 3. Therefore, the quotient of 1/2 and 3/4 is 2/3. Or, you can simply multiply the numerators. We have 1 times 4 is 4. And then 2 times 3 is 6. 4/6, lowest term is 2/3. Next, we have 5/2 divided by 9 over 4. Copy the dividend. We have 5/2 and then multiply to the reciprocal of 9 over 4 is 4 over 9. 4 and 2 have GCF of 2. So we divide them by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Multiply the numerators. 5 times 2 is 10. 1 times 9 is 9. Simplify 10 over 9, we have 1 and 1 over 9. Next, we have 9/2 divided by 3/4. Copy the divisor, we have 9 over 2. Multiply to the reciprocal of 3/4 is 4/3. 4 and 2 have GCF of 2, so we divide them by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Then, 9 and 3 have GCF of 3. So, divide them by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Multiply the remaining factors. So, we have 3 times 2 is 6. 1 times 1 is 1 or simply 6. Let us now proceed with dividing rational algebraic expressions. So we have find the quotient of 6ab squared over 4cd and 9a squared b squared over 8c squared d. Our dividend is 6ab squared all over 4cd. Our divisor is 9a squared b squared all over 8c squared d. And then get the reciprocal of our divisor. So we have 8c squared d all over 9a squared b squared. Then we multiply 6ab squared all over 4cd by 8c squared d all over 9a squared b squared. Get the prime factors of our first numerator. We have 2 times 3 times a times b times b. Prime factors of 4cd is 2 times 2 times c times d. And then prime factors of 8c squared d, we have 2 times 2 times 2 times c times d. Prime factors of 9a squared b squared, we have 3 times 3 times a times a times b times b. And then reduce the factors by cancelling. We have 1 pair of 2, 3, a, b, b, 2, c, and d. Multiply the remaining factors. We have 2 times 2 times c all over 3 times a. 2 times 2 times c is 4c all over 3 times a is 3a. Therefore, our final answer for the product of our given is 4c over 3a. Next, we have 81xz cubed all over 36y divided by 27x squared z squared all over 12xy. Get the reciprocal of our divisor. So we have 12xy all over 27x squared z squared. Multiply to our dividend. So we have 81xz cubed all over 36y times 12xy all over 27x squared z squared. Let us have their product. Prime factors of 81xz cubed, we have 3 times 3 times 3 times 3 times x times z times z times z. Prime factors of 36y, 2 times 2 times 2 times 3 times y. Prime factors of 12xy, 2 times 2 times 3 times x times y. Prime factors of 27x squared z squared, we have 3 times 3 times 3 times x times z times z. And then, cancellation, we have 3, 3, 3, 3, and then 2, 2, x, x, z, z, and then we have y. And then, get the remaining factors, then multiply. For the numerators, we have z times 3. And for our denominator, we have 2. Z times 3 is 3z. And then our denominator is 2. Therefore, the product of 81xz cubed all over 36y and 12xy all over 27x squared z squared is 3z over 2. Next, we have 2a plus 2b all over a squared plus ab divided by 4 over a. This is our dividend and this is our divisor. Copy the dividend and then get the reciprocal of our divisor. Reciprocal of 4 over a is a over 4. And then change the operation to multiplication. So we have 2a plus 2b all over a squared plus ab times a over 4. Then, common monomial factor of 2a and 2b is 2. So we have 2 quantity a plus b over prime factor of a squared plus ab. We have a times a plus b. And then a and 4 are already prime. Just copy. Next is simplify. So cancel a plus b. And then a, 2 and 4 have GCF of 2. So we have 2 divided by 2 is 1. 4 divided by 2 is 2. Then multiply the remaining factors. So for our numerator, we only have 1. For our denominator, we have 2. Therefore, the product of our given is 1/2. Next, we have 2x squared plus x minus 6 all over 2x squared plus 7x plus 5 divided by x squared minus 2x minus 8 all over 2x squared minus 3x minus 20. This is our dividend and then this is our divisor. Get the reciprocal of our divisor and then change the operation to multiplication. So we have to factor our numerators and denominators. So factor of 2x squared plus x minus 6, we have 2x minus 3 times x plus 2. Factors of 2x squared plus 7x plus 5, we have 2x plus 5 times x plus 1. Factors of 2x squared minus 3x minus 20 is 2x plus 5 times x minus 4. Factors of x squared minus 2x minus 8, we have x plus 2 times x minus 4. And then simplify, we have to cancel x plus 2. Next is 2x plus 5. Next is x minus 4. And then multiply the remaining numerators. So for our numerator, we have 2x minus 3. And then for our denominator, we have x plus 1. Therefore, the product of 2x squared plus x minus 6 all over 2x squared plus 7x plus 5 and 2x squared minus 3x minus 20 all over x squared minus 2x minus 8 is 2x minus 3 all over x plus 1. Let us now summarize the steps in dividing rational algebraic expressions. First, completely factor both the numerators and denominators of all fractions. Second, change the division sign to a multiplication sign and flip or reciprocate the fraction after the division sign. Third, cancel or reduce the fractions. Remember that to reduce fractions, you can cancel something in the numerator with something in the denominator. But in order to cancel something in the numerator and denominator, the two factors must be exactly the same. Step 4, we have rewrite the remaining factors into lowest terms. Let me leave you an exercise to work on and practice your skills in dividing rational algebraic expressions. Just follow the steps we have in dividing rational algebraic expressions and do not forget to write your answers on the comment box. So that's all for today. I hope you enjoy and learn a lot in this video. See you again on my next video. Bye!